Okay, so this is the second lecture on the chapter on middle childhood. These next several slides are all about cognitive development. And bear with me as I do my best to explain some of this cognitive stuff. Remember, cognitive is about thinking. And so it's kind of abstract, right? We're doing a cognitive activity even by talking about cognition. And measuring how people learn to think is even more sophisticated and abstract. So there's a whole bunch of things that are happening in children's development and their ability to think during this period between 5 and 12, or between 5 and 11, 6 and 11. So some of the cognitive advances, you have something called spatial relationships and causality, which simply means that children would be able to recognize things on a map. They can tell symbolically when where things are located. So I always think about, the maps they used to have in malls, and your 8-year-old could help you figure out how to get to the food court from the main entrance. Causality is a cause and effect. So if a child doesn't understand cause and effect until they're 7 or 8 years old, it's pointless to try to use that as a form of discipline when they're 6. If they haven't cognitively understood that when you do this, this happens, right? Which interestingly, it seems to be something your cats understand. Categorization. So categorization, there's a couple different kinds of categorization. One is called oopsiration, I think is the proper pronunciation. And this is based on the term series. So in about first grade, from first grade on, a kid can start to put things in order from tallest to smallest. They can begin to sort things out based on some sort of characteristic. There's a phenomena called class inclusion, which is that children begin to distinguish. So I don't know if it was in your book or if it's the example that I came up with. I think it's the textbook example, and it says that, a child can understand that roses are flowers, but not all flowers are roses. And up until this point, a kid wouldn't have been able to understand this. We also begin to see this really sophisticated way of thinking about reasoning, right? So reasoning is a kind of logic where we draw conclusions based on a certain amount of information. Then there's inductive and deductive. So by about 11, a child should be able to draw conclusions about the group based on the individual, and conclusions about the individual based on what group they're in. So these are not likely to end up on a quiz question. I'm not going to ask you the difference between induction and deduction, but I do want you to sort of get a sense as to what's happening, what a kid can't understand up until this point, right? And the reason I think this is important to know, it's important to understand, or for you to know, what a child can and can't understand if we're going to try to influence their behavior or try to teach them or parent them, because we may be assuming they understand things that they don't understand, right? Another important one, and you've seen videos on this phenomena, is conservation. And that's where you have the big, tall, skinny glass and the short, fat glass, or you have the crackers that are broken in two, and a child a child younger than 7 or 8 doesn't know that that's the same amount of fluid in the tall, skinny glass as it is in the short, fat glass. But by 7, 8, 9, 10, they start to get that. They begin to understand that, for instance, ice is still water, that those are different kinds of the same thing. That would be identity. Or something called reversality, and that's that the ice will become the water and the water can become the ice. It's still the same thing. And then a phenomena of decentering, a concept of decentering, means that they no longer just focus on that water is fluid and ice is solid, but they can begin to see that it's kind of the same thing, right? So I think it uses in your textbook, it uses an example of clay. That one was an example of clay made into a ball or clay made into a snake. A child can understand that that's clay, it's a snake or a ball, that's identity. That it can go from being a snake to a ball or being a ball to a snake, that's reversality. And then decentering is just noticing that it's less about the shape of the clay, but noticing it's still clay. So you focus on, you are less centralized awareness of the one aspect. That's what decentering means. And then we also see in this age, children are beginning to, they can comprehend some numbers and some mathematics. They can count in their head. They can what's called count on, which means, you get to a kid by 5, you say, After you get to the number 5, now can you count by twos? So they can count on in their head, and they can count backwards and forwards. So that means they can learn to subtract and they can learn to add, but they have to have this concept of counting on, right? Before we can begin to teach them math. So when you see smaller children, 3 and 4, who can do math, I guess we can assume that their cognitive skills got way ahead of everybody else's. Okay, so then we get to this guy, Pinochet, this French fellow, and I have tried my darndest to find a really good short little video that explains his moral reasoning. Most of what you find on moral reasoning is Kohlberg, and Kohlberg had a little bit more complicated, more sophisticated moral model. But effectively, Pinochet says that that this is a time of 3 different stages of moral reasoning. And moral reasoning, for our purpose, is how we decide what is right and wrong. Right? So a child between the ages of 2 and 7, the world is black and white. Rules are meant to be followed. You should do what your teacher says, period. I remember an argument I got into with my mother when I was probably 6, and she was going to tell her father something that wasn't true. And I got very angry with her because that's a lie, and you can't tell lies, right? Just absolutely, just that, very rigid. The next stage, somewhere around this to about 10 or 11, this is one where children focus more on what's fair, right? Or what they perceive equal treatment. Everyone needs to be treated the same, right? All the rules equally apply to everyone. They should apply to parent and they should apply to child. And you can imagine if you have a 10-year-old getting into an argument where a kid would say, well, if I have to go to bed at 9 o'clock, so do you, because rules have to be the same. No point in arguing with the kid about there's a difference between equality and equity. That's the later stage, and this is the more sophisticated stage. So at the time, at this higher sophisticated understanding of moral reasoning, a kid begins to understand that it's not so much that the rules are equally applied, that it's that the consequences are the same. That's the difference between equality and equity. Equity means the net result is the same. Equality means everybody gets the same, right? So equality has the 2-legged person and the 1-legged person both starting at the start line the same. That's equal. Equity says that the 1-legged person gets put ahead so that they can end at the same time. It's about the ending. And so here, intentions and context and so your textbook uses an example, and I've found this several different places. It's the same basic example. The 2 children, one child is sneaking around in his dad's office, and he spills something on his dad's favorite old books, right? And then he hides it. The other child has been asked to go to his father's office to get something, and he spills something on his father's book. Who should they be punished the same? And by the time a child gets to 10 and 11, they understand that the intention, that one child was sneaking around and caused a problem. The other child was doing something that they were asked and caused a problem. So we start to get to a more sophisticated understanding of what is right and wrong. And that's what moral reasoning says. Okay, so back in a previous chapter, we were talking about a theory of cognitive development that basically says that the brain is like a computer and it has to have all the hardwire in there for it to work right. That's what this theory says. The information processing theory. It notes that a child between the ages of 5 and 11 has developed that their executive function has gotten faster. So that's their frontal lobe, right? This is sort of this is the part of the brain, what's it say? The conscious control of thoughts, right? That a child is better able to become consciously aware. They're better able to attend, or what's called selective attention. They're able to tune stuff out. And this is all thought to be related to that increasing white matter and decreasing gray matter. That the brain is simply more efficient. It's kind of like the artificial intelligence started to learn, right? So it's using its resources more efficiently. And this results in a working memory, which is really what most of us, that's our daily memory, is our working memory. It becomes faster. A child begins to understand the concept of memory, right? And that's what meta memory means. And so the idea that they understand that some people don't, some people's memory is different. So going way back to earlier chapters, when we talk about theory of mind, right? Meta memory is that I have a slow memory right now. Okay. And then finally, mnemonics, which is a fancy term for children can begin to use strategies for remembering, right? So you have like things like mnemonic devices. Now is a good time to be using to help a child learn mnemonic devices. Every good boy does fine. FACE, let's see, my dear Aunt Sally, I forget all that one, don't remember that one, or never eat soggy waffles. We can use external memory aids, right? So little things like tie a string around your finger, or that they can begin to associate, because that's really a sophisticated thing, right? That if they see something by their school bag, they understand that that means something else, right? It's all symbolic representation. And then elaboration and rehearsal, right? We can begin to help children remember things by all of those techniques that you should have learned in your psychology class about rehearsal as you use it over and over again. Elaboration means you tell yourself a story, right? I think I'm going to stop here because I've gone over 10 minutes. When I come back, we'll talk about some other theories about cognitive development in middle school children, middle childhood, middle child.